Next, we have an example containing the zero compound coupon bonds. There are no interest payments during the life of these kind of bonds. The investor receives a single payment when the bond matures, consisting of its original investment, and an interest rate is always compounding semi-annually. So this is important. You have to remember, in the zero compound bond, the interest is always compounded semi-annually. Let's read an example if we can understand. Doug bought a 15-year zero coupon bond paying 4.5% interest, compounded semi-annually. So again, zero coupon bonds have semi-annually compounding done for 12,824.50. What is the face value of the bond? So in these cases, the buyer, which is Doug in this case, will receive the final amount as its face value. So basically, the face value is equal to your compound amount. Okay. What was the formula for that? Principal times 1 plus r by n raised to power n t. That was the formula. What is the principal in this case? The present value is 12,824.50. Interest rate is given to be 4.5%. That will be in decimal 0.045. Then we have time is 15 years, and n is, because the compounding is done semi-annually, n is 2. So the face value is equal to this amount 4 here times 1 plus 0.045 divided by 2 raised to the power 2 times 15, which is 30. So we can always use the calculator. Let's calculate the inside the parenthesis thing first. 0.045 divided by 2 plus 1 raised to the power 30 is this times your present value. So you will have 24,999. So approximately 25,000 will be the face value for this particular zero bond in 15 years. Next is an example of inflation. Suppose that inflation rate is 3.5%, which means that overall level of prices is rising at 3.5% a year. How many years it will take for overall level prices to double? So inflation is what? So whatever you buy today, say for $1, in few years the price of that thing will change, right? Now here they are saying it is changing at the rate of 3.5%, which in the decimal format can be written as 0.035, right? Now we are saying how many years will it take to double the prices, meaning if I am paying something today at $1 for something, how long it will take for that to be doubled, meaning $2. So we can take principal to be $1 and we can take amount to be $2, and inflation is done annually, so n will be 1. So what is the formula for amount? Amount is principal times 1 plus r by n raised to the power nt. Let's put everything. A is 2 equal to principal is 1 plus r is 0.035 raised to the power divided by 1 and raised to the power t. We do not know how many years. The question is to find how many years it will take to prices to be double. So if you see this, you can write it like 2 is equal to 1.035 raised to the power t. this becomes like an exponential equation, right? Because the variable, the unknown, is in the exponent. So what can we do to solve that? We can take log on both sides. Natural log is what I am using in this case. What will that help me make? Natural log of 2 is equal to natural log of 1.035 raised to the power t. So t, because of the power property, will come up front. So t will be equal to natural log of 2 divided by natural log of 1.035. So we can use the calculator to do that. Natural log of 2 divided by natural log of 1.035. 20. So at this inflation year, roughly 20 years it will take to double the prices of the things. Next we have effective rate or annual percent yield, APY. The effective rate is what? It's basically the simple interest needed to produce the same amount of interest in 1 year as the nominal rate does with the frequent compounding. Right? We know, we understand that if I deposit $100, so let's use the board. If I deposit $100, right, at say 8% compounding interest, how much money I get, say semi-annually it is happening, right? So it will be 100 times 1 plus 0.08 divided by 2 raised to power 2, right? So that will be the amount if I have $100 put in for 8% compounding semi-annually. So that will be like 100 times 1.04 raised to the power 2. That is the answer. So we have $108.16 at the end of 1 year if it is happening semi-annually. But I want to know how much simple interest, if it is not compounding, if it is just having simple interest, how much simple interest it will take for $100 to reach 108, the same amount, equivalent amount, how much interest rate will take for the same year, right? How much is the interest in that case? I is given to be 8.16, right? We are increasing from 100 to 108.16. And what is the formula for I? Principal times R times T is 8.16. So 100 times R is equal to 8.16. R will be 8.16 divided by 100. So that is what? 0.0816. That means 8.16%. Now that is different than the 8% compound interest. So compounding semi-annually at 8% gives us this amount. For the same kind of amount, if we want for the simple interest, the effective interest rate. So this is called effective interest rate for given compounding interest rate. Okay, that is what your effective interest rate is, RE. So effective rate corresponding to a standard rate annual interest compounding m times per year is given by this formula. So you have to remember this formula. Let's see how we can use that. In July 2016, American Express offered its customers a money market saving account at the rate of 0.90%. So R is given 0.90%. Assume that account compound interest daily. So that means compounding periods are given 365. And the principal is 100,000. Find the APY. Basically APY and RE, effective rate, are one and the same. So how we use the formula is, we have R, we have M, the formula is given as this: 1 plus r by m raised to power m. Remember, what is m? M is the compoundings per year. So that will be 1 plus, in this case, 0.90%, meaning 0.0090, 0090 in the decimal format, divided by 365 raised to the power 365 minus 1. So let's see what our effective interest rate comes to be. 0.0090 divided by 365 plus 1 raised to the power 365 gives me this minus 1. So the answer is 0.00904. That is, in the percentage, 0.904%. Okay. So effective rate for daily compounding comes up to be this. There is a formula here that's also called APY. Here RE and APY is the same thing, and on your calculator, actually I wanted to show you, there is an app which can help you find this, that is called effective rate, EFF. So how do you use it? You press apps, that takes you into the finance, enter. If you go down this list, here you at C you have EFF. So you select that. The first number is the given rate. So the given rate, if you're using the calculator, is same as given. So you have to give calculator in the percentage format. So here it will be 0.90, and the next argument is the compounding periods, 365. Let's see, here you have to write 0.90 comma 365 parenthesis closed, enter. That gives you the same number. Okay, so you can always use calculator to calculate APY or effective rate. So remember, what is the formula in the calculator? You have apps. Let me show you the sequence. Apps, go to finance, go down in the list at C, select that. The first argument is the given rate in the percentage format only. You do not have to convert that to decimal. Comma is here above 7, and then we have the number of compoundings per year, and you can enter it. Okay.